Welcome to ASQ section 1106, February meeting, and Keith Fong will be our speaker on putting analysis into FMEA. I'll let Keith introduce himself and get going into the talk tonight.
Hang on a second. All right. So, good evening. My name's Keith Fong, and I'm going to be talking about putting analysis into FMEA. And my background is I started out life as my engineering life as a product engineer in the petrochemical industry, as designing refinery waste gas flares. And then later, I joined the Delphi Automotive Corporation as a product design engineer for anti-lock brake solenoid valves, and I did that for a few years. And then around 2000, I got into, I joined the Innovation and Continuous Improvement Methodologies group and was a coach, trainer, and practitioner of continuous improvement. And that kind of leads into doing the FMEA. I had to do it as a product engineer, and then later enjoyed the effects of poorly done FMEAs. So let's go ahead and get started, because we'll go ahead and take a look at the agenda. So again, this is the agenda for this talk: putting analysis into FMEA. Why FMEA? So for those of you who don't have a background in it, I'll give you we'll have a brief overview, and then, what is analysis? After all, FMEA is part of the name. And then the next part will be looking at the FMEA context. I think this is a really important part of doing, or especially coaching, FMEAs. And then there's the actual FMEA practice. So there's some practices, there's some tools that, boy, I wish I had known them when I started. So let's get going. Why FMEA? So of course, FMEA is failure mode and effects analysis, FMEA being the acronym. And it's an analytical process where we try to identify the potential of failures, their severity, their likelihood, so that we can drive actions to prevent and or mitigate their occurrence. And it's a qualitative analysis. It's not a quantitative analysis. So we're doing forecasting, but it isn't as quantitative as, say, weather forecasting. It's really driven by the knowledge and experience base of the team who's creating it. So that has its pluses and its minuses. So there are different types of FMEAs. So this is really important. We those of you who practice it, you probably mostly talk about doing design FMEAs or process FMEAs, but there are others. And an important one is doing a concept or system FMEAs, where you take a look at and say, we're trying to accomplish something. What are, assessing what are the possibilities, what are the requirements, what are the risks? So in this particular case, an example could be single-serve beverage containers or single-serve juice containers. There's more than one way to do that kind of product. And we could use a pouch, you can use a box, you can use a bottle, you can use a can, and you can use variations on all of those. So knowing what the key requirements are and what the key risks are, you can choose a design or a concept that will then have the minimum amount of risk when you actually try to create a specific design, which, when you go from the concept and system FMEAs, that should help you choose, again, one of the concepts or one of the designs. And then you're going to do a design FMEA where you're trying to reveal, okay, where are the areas where it could fail, and what can you do to either prevent that failure, or if it is going to happen, because everything fails, right? Move it to a time when it's past the, expected life. And of course, once you have a design, you have to make it. Again, if we're talking about a product, you have to actually turn it into something. And there's a guy named Fred Schenkelberg who created Ascendo reliability website, and he talks about reliability all the time. And one of the things that I think he articulates very well is manufacturing cannot make a product any better than the design is capable of. They can only make it worse. So you can make a perfect design, but if it can't actually be assembled or manufactured, or if in the process of manufacturing things happen, your design, even if it's perfect, is not going to be perfect to the end user. So with design, we're actually setting the maximum capability. We're setting the theoretical limit of what is possible with the design. And in the process, we want to set up a process so that we try to attain that theoretical design limit with every single product we produce. Or if you're doing a service, every service that you provide. So the FMEA format, again, I'm talking about a little juice bottle, but if you have, for example, in this case, a process failure mode and effects analysis, you go from left to right where you talk about what's the process and function, what's the potential failure mode, what's the effect of the failure, how you rank the severity, what's the potential cause or mechanism of the failure, how frequently you expect that to occur, what are your current, in this case, again, this is a process, what are your current process controls, and then what's the capability of those process controls in a ranking. And if there's something that makes you say, hey, we have more risk than we think is acceptable, then you would add like what's a recommended action, who's responsible, when you're supposed to get it done, and then further document what was done, and you update your rankings. So again, there's not one single format. I mean, there's recently the AIAG and the VDA harmonized on a new format, and you don't necessarily, even if you're in automotive, not all of the, I don't think any of the OEMs are requiring that you use the latest format. So there is a whole range of formats, but they all kind of follow this same arc, from function to mode to effect to cause to control, and then to recommended action. So that's why doing the FMEA. Again, we're trying to forecast what problems we're going to have. But what's analysis? So, I think we all have done analysis our entire lives, at least, if we're engineers or well, any job that requires looking at how processes work or how things work. And it's just a detailed examination of something to understand its nature or its essential elements. And it's even simpler to say it's answering why and how, right? We're just going to answer the questions. Why is this happening, or how is this happening? Now, in this presentation, there's a scope. As I mentioned before, I want to look at the FMEA context. So that's a macro view. I want to look at it from a higher level, like, okay, we're doing this at a business level. And then I want to look at it like how we might apply analysis to a specific FMEA. So we're going to put some analysis into this FMEA idea and process, and then we'll look at how we can put some analysis into the specific FMEAs and some of the tools that can facilitate that. So let's go on to talk about the FMEA context. Why do engineers resist FMEA? So if you've worked with, I guess I should, before I go any further, I should probably say, I'm going to talk about engineers and engineering a lot in this. It's not that other people don't use FMEAs, but it is something that we do use a lot in engineering, and particularly in industries like aerospace, automotive, healthcare, manufacturing. These are common. So it's not to say other people don't use FMEAs. It's just the principal people who are the focus of doing FMEAs are engineers. So why do engineers resist FMEAs? Because in the abstract, I say that FMEAs should be the beating heart of projects, which should be means that I don't believe they are. In fact, I say most engineers treat them as an ugly wart, useless and, ugly. And mostly engineers are creating or updating FMEAs, whether they're, design or process FMEAs to satisfy company policy, customer contracts, or regulatory requirements. The engineers are compelled to actually create the FMEA. And the problem is these FMEAs, we're assessing risk. We're assessing, bad things potentially happening. These FMEAs are not driving timely and appropriate risk mitigation actions. And that seems to be a huge loss. So to put some, my personal experience into this, my first FMEA, I was doing this not while I worked in the petrochem industry. We didn't do them, but or at least at the company I worked at, we didn't do them. So I joined Delphi and I joined the anti-lock brake group, and so I was involved in designing solenoid valves. So again, at the time I was a product design responsible engineer. So whatever here, create something and make sure there's a set of drawings and so forth that we can make it. So I was a product design responsible engineer. There were also, the manufacturing design responsible engineers and, of course, industrial engineers and every other, test engineers, validation, all these other groups. But my role was I'm responsible for design. Again, for the anti-lock brake solenoid valves. The first FMEA I had to do, we were driven by some kind of deadline. It was, I think, for a design review. It's been so long now, I don't remember. I had no FMEA training. It was like, here's the format, here's the form, go fill it out. And there were two of us, myself and my friend and coworker, Ray Sines. And we sat down in a conference room, and it took us more than 1 hour to complete 3 lines on an FMEA. So as you can imagine, it was not going so well. And like the risk, these are valves inside of a brake system. And I think one of our first ones was leak. What happens if our valve leaks? Well, then the brake is going to fail, and then the car's not going to stop, and potentially it's going to be a crash, and, somebody could die. So, our severity was driven by this like catastrophic cascade thinking. And we had no guidance. We just like, well, this is part of the brake system. It would be really terrible. As I said, we had no guidance on how we should limit our, the bounds or the scope. So it really didn't add anything to our understanding. We just did not learn anything in doing this FMEA. It didn't make us any smarter. It didn't make us any more perceptive. And, it's a frustrating and miserable experience. So it didn't exactly like, oh boy, I want to do FMEAs at every opportunity I can. It's like, this just doesn't seem to, I understood the idea, but I understand how to make it work. So here's a really, really, really important idea. What do functions and failures mean to the engineer? And what happens is engineers live and breathe function and failures. I mean, when I was designing the product, I wasn't designing it, just to be the window dressing. I'm designing a solenoid valve. I know it has to open under certain pressures. I know the viscosity of brake fluid changes with temperature. It has to have a certain response time. I need to, sign how many turns do I need on the electromagnetic coil, and all of these things. Like, we got to make it so it can do something. And I'm also anticipating, well, maybe I can't get it to fit, or maybe this is going to happen. So this is entirely what I'm thinking. And this isn't, and I deal with a lot of engineers, and this is what they think too. Our job is to make something happen. We're bringing stuff together so stuff happens, and we don't want bad things to happen either. The thing is, quality tools formalize what I would argue are our good life practices. If you say, hey, what makes something good, you would say, well, I want it to perform a certain way. I want it to last a certain amount of time. I want it to, not cost too much. All of these things, we're constantly working towards. And even, when it comes to risk specifically, we survive to adulthood. We had plenty of opportunities to get ourselves killed. But, doing things like looking both ways before crossing the street, not jumping into a pen with dangerous animals. I mean, all of these things where we could have died. No, we didn't, because we were exercising risk assessment and trying to avoid terrible outcomes. So again, to me, an FMEA is kind of formalizing good life practices. However, quality profession has this really, really terrible mindset. There's a lot of shoulding on everybody else. You should do this. You should do that. And it's not that they shouldn't, but the challenge that we have is there's this ideal that the quality professional, is imagining, and they haven't really established a firm link to the reality of the people that, I should say, we are supporting. Like what's going on in their lives? How are they doing things today? They're probably already trying to do a good job, right? If not a great job. And so they're doing things today, and maybe they're not applying the tools that we want. And, I feel like a lot of times the problem is, again, a lot of FMEAs are done because of, corporate policy, customer contracts, regulatory requirements. And so it's imposed on them, and the quality professional, of course, many of us didn't have training. So there was nobody there to guide us. Well, this is how you're going to formalize what you're already doing. And that's what I think one of the key issues. If you're going to coach, it's like, where is my person at? This person I'm trying to coach, where are they at? And how can I get them to where they can really take advantage of the power of these tools? So again, this is one of the things that I've so many times. In fact, I was thinking about a particular case where product design engineering team leader, they had a disaster at launch. It was so bad, all of the units in the field had to be brought back and replaced. And I asked to look at his FMEA, his DFMEA, and the failure mode was on the list. But, it just wasn't rigorous enough. It's like his control was perform validation test. And so the validation test did not test for that failure mode. So again, it's somehow surprisingly, because of the low quality of the prototypes and initial parts that were used for validation, it actually didn't fail until they actually got production quality parts going into production. And that was when the failure mode reared its ugly head. Again, every single part of that design had to be brought back. Every single one. So again, they could do better, but they didn't have we weren't able to connect how to get things to work. Another important issue here is, most, certainly in automotive, everybody's like ISO TS or QS, and, they've got these certifications. But the problem is quality audits are not driving FMEA improvements. I have never seen a non-conformance because the risk assessment was superficial. I have seen non-conformances because there were paperwork defects. So, again, what is a, quality management system is like, do what you say, or say what you do and do what you say. And so if you say, well, we did these steps and we documented that we actually performed these steps, hey, that's cool. But did the steps create meaningful outcomes? And that is kind of hard to assess in an audit. So, and of course, this might have been a feature of my time working at Delphi, but serious product and process design started at product launch. It was like suddenly all of these things that we should have been testing and knowing were getting revealed. And it wasn't uncommon that there would be significant changes that were required, like in stream. Really, really expensive moment to do that. Of course, the really profound design or process defects got out. And, it was left to the customer to identify them and demand the correction. As an example of this, and, there was a product that involved a circuit board, and the circuit board wasn't designed by one of our regular teams. It was designed by a contracting team, and they did not use our design standards. The supplier pointed it out, but we never failed a test in our validation cycle. Never failed a test. But when it went out to the customer was failing them regularly. And I can tell you, when we looked at the warranty returns, the part dates for many of those failures literally end the day we implemented to our design standard. I mean, it was just black and white. It was like, we're having all these losses, all these returns, all of these customer failures. And then on that date where we switched production to the correct design, literally problems just disappeared. But I will say this, never once, not a single time, in spite of dozens upon dozens of product being tested in a very substantial test facility, did we ever reveal that failure. It was just crazy. So we left it to the customer to find something. Well, in fact, even our supplier was like, you're not consistent with this, but like, hey, it's not failing. No, we had to do it we should have been doing it to what we already knew worked. And of course, that is to say, the true signal of deficient FMEA practices is stuff escaping. And are we actually being real responsive to it? A QMS audit is not going to tell you that you're not assessing things very rigorously. A big issue, and something that just troubles me deeply, is defective FMEA training. I mean, I think much FMEA training is not good, because I think training is perpetuating a lot of the FMEA deficiencies. So I actually had a chance to participate in the AIAG VDA harmonization evaluation. And, I saw it and I said, well, this is great, I suppose, but it doesn't solve the one problem I think we have. And that's people don't know how to do an FMEA. Just changing the format doesn't fix the problem that I believe we have in our, in our world. And I've got to say this, I think quality has a continuous improvement problem. There's a lot of things that haven't gotten better, even though we know they're not working. And we're training things that we have established don't work effectively. And when it comes to FMEA, the number one example for this is the risk priority number, which the risk priority numbers, you take the rank of severity, the rank of occurrence, and the rank of detection, and you multiply them together. So if you use a 1 to 10 for each of them, you can get a maximum value of 1,000 and a minimum value of 1. Except this is complete nonsense. Multiplying ordinal numbers is multiplying things that are not arithmetic. So it is perfectly legitimate in ranking risks to use colors. We use green, yellow, red all the time. Like, what's the status? Oh, it's green, it's yellow, it's red. That's a legitimate way to rank risk. You could rank risk by animals. You could say, oh, the apex predator, like the tiger, is the top risk, and the domesticated house cat is the most benign risk, right? And that is entirely legitimate. So you could have a number, a color, and an animal as legitimate ways to rank. So let's say you use number for severity, color for occurrence, and animal for detection, and multiply them together, and you'll get a perfectly valid risk assessment, right? And of course not. This is ridiculous. This is something that we have known almost, I'm sure, since the first day. And yet this continues to be taught. In what I would, I in preparing for this, I want to see what's out there. And I watched some YouTube videos, and it is like an act of self-loathing, because I just watched this and like, how can you put forth, even in a recent video, that an RPN is a risk assessment? It is so defective that if you've ever done one, you know it doesn't work. And it doesn't work. We'll assume that you don't appreciate that you're multiplying nonsense numbers together. But the key thing that it's not legitimate is that engineers will change the values so that they get lower numbers, especially if you have a threshold requirement. GM, again, back when I did my first FMEA, GM had a threshold. Well, maybe it wasn't GM, it might have been Delphi, but Delphi was spun off from GM. So there was a threshold. You had to be below like 64 or something, or below 80 or whatever. It was a number. And when you look at it and you're like, oh, wait, I've got a number above that. Maybe I've got a 96. Well, let's just drop everything by 1, and suddenly we're below the threshold. So if anybody, I mean, literally, if you've done it yourself or you've coached anyone and you're using RPN and you've used it with thresholds and you haven't seen this, I can't believe it. You're not paying attention, because again, engineers are going to be avoiding work. They're not like, well, I don't want to do this. I don't actually think it's that bad, So again, this is terrible. And it has not been a recommended practice, in automotive. I mean, since at least the 3rd edition of the the AIAG FMEA manual. So we're talking 30 years. I mean, a long time. It's been a discouraged practice. And yet there's still people today who are saying, oh, use the RPN. It will tell you how bad your risk is. So again, quality has a continuous improvement problem. Something else that I often see, and again, this drives me crazy, is brainstorming is like the first thing people say. Brainstorm the functions, brainstorm the failure modes, brainstorm. It's like, this is analysis. I love the creative aspect of brainstorming, but it has a place, and the place is not in analysis. Unless like I'm trying to break a log jam in my analysis, I can understand doing that. I can understand that. But as a practice on the most fundamental analytical steps, it is not a good practice. It just means like you're too lazy to actually do the analysis. So I read RPN and brainstorming, to me, if they're teaching that, I really question I would question the trainer or the consultant's actual abilities, because I just don't think that that's, again, those two things to me are signals of things that don't work, things that aren't going to get you the kind of analysis you need. And then the other part is there a lot of this is not Pareto principle conscious. And by what I mean by that is, we don't have unlimited time. We don't have unlimited resources. So when we do our risk assessments, we really need to identify the biggest risk. We have to deal with the most serious risk, because if we don't, then we're going to die. The problems are going to escape to the customer. And if you put too much stuff out there, if you detail every single little thing, suddenly you're going to have this enormous FMEA, 50 pages or whatever. It's huge. And that quantity is losing the forest for the trees, right? There's so many. How do you really distinguish? And you spend so much time. So there's a real need to like, okay, how do we quickly get to what's critical? So again, these are 3 things, doing ridiculous risk, assessment. Well, I should say ranking risk by RPN is just completely terrible. Brainstorming is not the first analytical tool. It's we're doing analysis, not really a creative exercise. And then again, we have to find intense focus on the things that are most important. So there's a couple of practitioners who I love their work. And so one is a guy named Richard Harpster, and he has a company called Harpco Systems, and he has a YouTube channel that, I seem to find the best of the FMEA material on. It's called Harpco Systems as one word, and I highly recommend it. But he has one of his videos, he's talking about the top 10 errors that are made in FMEAs, and you look at it, and this is 10 years old now, but it's still true. I don't see anything where I'd say, oh yeah, it's changed. It's not, that's no longer true. Things like the quality department as the FMEA owner. And one of the drums that I beat is quality does not create quality. The quality department does not control the things that create quality. The people who control quality, who control the levers of quality, are the people who are specifying the materials and geometries and so forth of a design. We have the people running the processes, who are setting the process parameters, who are selecting the equipment, who are selecting the technologies that are going to get used. Those people are controlling the levers that create quality. The quality department tells people what's going on. Like, hey, this is the state. This is, it's getting better. It's getting worse. But if you're expecting your quality department to create quality, you are seriously misguided. And so, the very first thing he points out is the quality department cannot be the FMEA owner. It really needs to be the person who's going to drive the action on it. I'm not entirely convinced that it should be for example, a design FMEA. I am not entirely persuaded it should be the product design responsible engineer, because I have seen ugly things where the product design responsible engineer as the leader dismisses legitimate concerns because, that person was the product design responsible engineer and dismissed everybody. So that kind of kills the vibe for the analysis. But nonetheless, it's not the quality department. And then there's things like, these are just, system kinds of problems, wrong participants, the wrong time, you're not integrating things, use of RPN, he and I are on the same page there. And some other like understanding issues, with the DFMEA and with the PFMEA. And so again, Richard Harpster, just a tremendous practitioner. And I learned a lot from looking at his work. And then there's Carl Carlson, who wrote the book Effective FMEAs. He's a regular on the podcast Speaking of Reliability with Fred Schenkelberg, and I think he and Fred have written a book that's to be released shortly about reliability. But in his book Effective FMEAs, he listed like the 10 things that are the biggest problems with FMEAs. And the first one, and I'm completely on board with this, is the FMEA is not driving a product or process improvement. If you're doing an FMEA and it doesn't drive it, why are you wasting your time? It's supposed to drive improvement. Second item, hey, high risk failure modes are not addressed with effective executable action plans. Those kinds of things. Failure modes are not identified in the FMEA, don't end up in the design validation plan or the process control plan. There's, not recognizing interface problems or interface failures, and that's where so many problems come from. Incorrect detail, too little, too much, not done at the right time. So he and Richard are sharing the same thing. Wrong people on the team, they both agree with that. Incomplete documentation, the poor use of participants' time. The poor use of participants' time drives resistance to doing the practice. So, so again, there's a lot of system problems here. Again, if we're looking at it at a high level, you're saying there are all these things that are just not working well. And from the first level for me is not understanding. Engineers are thinking about risk and failures and functions all the time. But the gap is the way they're thinking and the practices they're doing are not optimized, and they can be made better. So the key points I want to make in this section is FMEAs are not driving product and process improvements, or at least not in enough organizations and are enough departments in enough organizations. The engineers are focusing on the risks and problems that they perceive. again, that they perceive. They may not be perceiving all of them, but they perceive some of them. The FMEA deployments, the drivers, like the contractual requirements, policy or regulatory requirements, and the training are subverting the objectives of the FMEA. It's like, okay, I have to do it because I'm being compelled to do it. And then my training or lack thereof is not making me turn this into a useful tool. So again, our engineers are perfectly intelligent people. They're going to make decisions about how they're going to use their time. And if what we in quality push doesn't make them feel better, they aren't going to do it. That's just reality. The quality system, is poor at providing course correction, especially for risk analysis in the FMEA. The people who are auditing it as a rule, I mean, there are exceptions, obviously, but as a rule, they can't assess like, hey, are you asking the right questions? Are you, do you have, are you creating the right analytical tools to help you investigate this? If your procedure doesn't include the creation of those tools, they're not going to ask about it because it's not part of doing what you say you're going to do. And then, of course, the known deficiencies are persisting and are perpetuated. Again, RPN to me is just a trigger. I just, again, I cannot think that you're qualified FMEA trainer or consultant if you argue that RPN is a useful tool. It is a terrible, terrible, terrible metric. And it's again, one of those things where trying to use a single statistic undermines the whole quality idea. It's what we're trying to get done. It's like, oh, I'm just trying to reduce it to just this one number. And, it's just not the case. So let's talk about the FMEA practice. So, we've talked about kind of the situation, the environment, but I want to get into like, okay, well, let's actually think about what do we need to do? What kind of things do we want to coach? And this is where Michael's work comes into play. So there's some things first I want to say about there has to be something of an attitude adjustment. Sometimes I hear engineers saying, well, it's okay. It's not a big deal. And it's like, well, I'm sorry. It's not okay. And it's not okay because failures will occur. That's just given, entropy is a thermodynamic law. Things are going to get worse unless you actively work to make it better. And something I've observed in all the years, is just, living life is the highest performers expect something to go wrong. I've noticed regardless of the function, if you're talking about, as somebody filling out, paperwork, somebody, assembling something or making something, and making something could be baking a pie to building building a rocket ship. The very best people are checking the things that they have learned are critical. And so I've seen this with like designers, preparing drawings for the engineering team. And then, they check and make sure, oh, let me look at this, let me look at that. People who are not the high performers, they're just checking in and doing their job. They do what they're told, but they might not necessarily check, oh, is this in the right place? Is that in the right, is that in the right state and so forth? And so, you're basically setting a trap that springs itself later. But the very best people know what to look for. And they know to look for it because they are expecting things to fail. And that is a key attitude that we need if we're going to have high quality. It's just like failure's coming. And am I thinking like, where could it come from? Am I being, sufficiently paranoid? So I always kind of assume like when I'm working on a project, it's like, okay, what don't I know? What have I missed? And to always just kind of like be a little on edge, because something's going to drive failure. Now, the engineering philosophy, this is important to understand. And I'm so charmed by this idea. A month in the laboratory can often save an hour in the library. And that's a quote from Frank Westheimer, who is a chemist at Harvard. And one of the things I've seen with engineers is they like to jump in and start something. It's like, oh, let's get going. Well, hold on. Where are we trying to go? What are we trying to do? It's like, oh, we'll figure it out as we go along. And that's expensive. It takes a lot of resources. It takes a lot of time. That's the design break test or design test break, fix. So, there's also even more charming is the saying that runs around in software circles is weeks of programming can save hours of planning. So again, the idea is if you put a little bit of time, and again, I want to point out something here, the time scale. A month in the laboratory can often save an hour in the library. Weeks of programming can save hours of planning. So, there are some people say, well, if you flip this around, you're talking about analysis paralysis. No, an hour of study or a few hours of planning is not analysis paralysis. It's, an investment, and it's a high paying investment. So where does failure come from? This is one of those key ideas. Like, where do most problems come from? So I don't know, maybe 8 or 9 years ago, we had a director of engineering, a guy named Jim Zizelman, who just like a week or two became the CEO of Stone Ridge. But he's a smart guy. And he had us, he assigned a bunch of different people in his organization to improve different aspects of it. And one of them was design failure mode effects analysis. And so there was a group of us who worked on this. And, when we looked at like, where are these problems coming from? There's basically 2 places. So one place that they come from is the failure you already have. Like, the manufacturing plant is struggling with something and, they can't, they don't have capability or whatever. So it's stuff that's already happening, or maybe you have a deficient design, like it's being used in ways that, it wasn't intended to, or beyond where you really should. So, you got to talk to operations. You got to talk to warranty group. You need to talk to, you need to look at the customer returns and complaints, or maybe even talk to the customer, right? To see what's going on and saying, okay, these are the ones we have to deal with because they are live. They are real problems today. And if we're going to have a next generation, we need to deal with that. So that's one source of failures. Although I will say, when you go and ask what's going wrong, you need to be careful to also know what is going right, because you don't want to make a design change where you throw out the good stuff with the bad stuff. And now you have new bad stuff and no good stuff. And it happens, it happens. I'm sure there's at least a few of you who've been in the situation. Well, we made this design change and now we can't, we can't do anything. We can't deliver any good parts. So it's, yes, I've been there too. Of course, there's the one other thing that you get most problems from, and that is the parts of the product design or the process that are new or changed. And if you just assume like, oh, we're going to change from, for example, from one supplier to another, you just assume the new supplier is worse. The new supplier is going to bring new problems. Maybe not the same problem, but they will bring problems. And you just assume that your life will be better. I'm not saying it will be painless. It will be better. So things that change. This was not on that list that we created, when we were doing that DFMEA analysis is people, but I have long observed that when the people change, you get variation. And this is so widespread. This is so common that, I have to say it here, even though it may not show up on your DFMEA or your PFMEA, but the people doing the job, they affect it. First shift versus second shift, one technician versus another technician. This is rampant. Again, it's generally a signal you have poor people development in your organization, but it's like super, super common. So, if you're used to one person doing the job and another person gets into the job, there's a risk. There's a risk. You've trained up this person to do things just the way you want, and now it's different. Customers. So if you get a new or different customer, that is a source of risk, right? The customer may not understand how you use this. Your other customers have come to understand, or this particular customer is like doing something really innovative with what you're producing. So your customer changes, you've got new risk. If your suppliers change, you have new risks. I cannot tell you how many times we have changed suppliers to save money, because in automotive, right? So where I used to work, the pressure on deflationary pricing, right? Every year you're supposed to reduce the price of whatever it is you're selling to the OEMs. So if your current supplier can't do it, your purchasing group is looking for somebody else, and maybe somebody else comes up with a lower price. But that change in supplier, a lot of times, whatever money we saved, we lost in scrap, or we lost in, warranty. So changing suppliers, high risk. New application, high risk. We supplied a product to one of our customers, an engine manufacturer, and then they supplied it to their, to vehicle manufacturers, and most of them were okay, but there were certain applications where, let's just say, warranty was insane. It was just like, and it wasn't just our component; it was also, the other parts of our customer's product that they sold to, to their OEM customer. It was like, it wasn't just our components; it was the whole product our customer sold, because who knows what was in. And I remember talking with one of the engineers about it, one of the customer engineers about it. He's like, yeah, we've tested it, we've measured everything, and we can't tell what's different, but it's killing our, it just murders our product. So, the application change is a big deal. Location. So this is more like for manufacturing, but if you're manufacturing one place and you move it to another place, always a risk, always. Even sometimes just moving in the same building. That's why you have to revalidate when you shift lines around in automotive. The environment. So, if you design something, like I live in El Paso, Texas, if I've designed something that works great here in El Paso, it's dry, it's desert, it's high, low humidity. And then let's say it goes from here to the Yucatan Peninsula, which, is low, hot, humid. It may not work the way that you expect it to work, or hope it would work. Or even if you went from here instead of the Yucatan, maybe you end up in, the far reaches of Canada, where it's cold and, still dry perhaps, but it's not the same as here. Materials. Again, this is another big area where things go astray. Is, oh, we could change the material. It's like, okay, is it going to work? So it may not. Design features. And this is kind of obvious. If you change your design features, something's going to, it's a source of risk. And, a lot of times you're making these design changes to address one problem, but a lot of times you create new problems. This, again, anybody who's had any time in product, in engineered products has encountered this. Functional requirements. Again, another obvious change where sometimes they're saying, hey, we want more. I remember one case where the customer wanted to increase the vibration capability of products. And like, that's not a minor requirement change. Manufacturing methods. So if you go from one manufacturing method to another, there's all kinds of, there's no one way to put something together. There's no one way to form things. There's no one way to create a shape, so changing methods can affect you, introduce risk. Terms and conditions. Like, again, another customer wanted us to change our warranty requirement by a factor of 4. Well, that's a huge delta if you're struggling to meet your current one. And then packing and shipping. Again, it seems benign, but that actually is a source of problems. Things get damaged, or they get, the packaging material is negatively affecting the product. These things happen. So just considering these things, problems that are existing, and then the things that are getting changed, those are the places where most of your problems are going to come from. And whatever bad practice you're doing today, this perfunctory FMEA, if you at least think about these things, you're going to get, you're going to begin to address, you'll at least be conscious at a little bit higher level. I did want to say there's a difference. We talk about design and process FMEAs. The design FMEA, you really have to think about the whole life cycle of your product. It's like from initial through disposal. And I must confess that, you know, when I was doing product design engineering, I'd really focus on the use section and not so much about the initial and not so much about the disposal, right? Because that's the part where we're focusing on. But really, if you're going to do a good job, you know, and really attend to all these problems, you really do need to think it's cradle to grave. You know, you have to think about risk through the entire life cycle. And, you know, the Europeans, you know, is becoming much more stringent about things like disposal, you know, as well as, you know, what its originating materials are. The process FMEA, you know, really assesses the risks that you get from things coming in the door till things going out the door. I mean, it's not entirely true, but really that's the typical span. And so, you know, and the problems that you create that get out past your door are usually because you didn't satisfy some design requirement. And that thing would come to you through your DFMEA analysis. So when we do an engineering analysis, I gotta say, we do not brainstorm. Brainstorming is a creative act. Again, sometimes you need a creative act to kind of break the logjam, but it's not what we're doing. We're asking why and we're asking how. So that's really key in your risk analysis. And here's a big booster. Nothing is entirely or even mostly new. So I have had the pleasure of working on a project that was in almost every respect new. It was a new product, although it had been made before. It was now being made by about 3 orders of magnitude larger. So, you know, effectively it was a new product. Although again, it had been demonstrated at like tiny sizes. Now it's going to be 1,000 times bigger or several thousand times bigger. It was being built with new machines in a new facility. Well, a converted facility, but it was a new manufacturing location with new people, new equipment, just everything was new. So, but if you step back and look at it, well, not everything was entirely new. The equipment, you know, the functions of the local functions of the equipment were actually pretty known stuff. So you'd have to get back, if you step back and look at the overall, it's like, oh, everything's new. But in reality, you could actually, if you narrowed your focus, you say, oh, this is not entirely new. There's things I know and things other people know that we can bring to bear to help minimize risk. So nothing is entirely new. And the more you know, the better you're going to be at this. And the way to be better at this is look at multiple existing solutions for the problem you're trying to solve. Because again, it's very rare that people are trying to solve a problem that has never ever been solved.